So let's make this really laid back and interactive, because I actually have to admit I don't really know what everybody knows about Google Web Toolkit and what aspects of it might be most interesting. I'd be happy to talk about really any aspect of it, but I have sort of a walkthrough, assuming that you know nothing about it, and we can go faster or slower during various parts depending on what people's interests. So let me start by, well, first introducing myself. Bruce Johnson, engineering manager from Atlanta, where we work on GWT. And now let me ask you, do you already know about Google Web Toolkit, the basic idea? Could you raise your hand if you do know a lot about it already? OK. So I think that would justify some amount of introduction to it. So I think so GWT is it's kind of a weird concept, actually. And I mean, even if I didn't say that, you might. So I like to start out the presentation by motivating why you need something like GWT, which is fundamentally a Java source to JavaScript cross-compiler. OK, that sounds like a wacky thing to do. If you're a big fan of JavaScript, it might even seem abhorrent to you. But hopefully, by the time we're done, it will at least make sense why we did it. OK, Web 1.0 world treats browsers like HTML dumb terminals. Now, that worked well because you could write powerful Java code on the server, use all your abstractions, so long as you could spit out HTML. And the basic interaction model was use your powerful tools to create sophisticated HTML spitter outer code on the server. But you were using tools like Eclipse and all the power of Java and so on to do that. But the UI itself was kind of impoverished because there's not much you can do with a static HTML page. This leads to some very concrete usability problems that you've probably seen. This one is one of my favorites to dislike, which is don't use the back button. And that happens because the act of doing an action within an application is inextricably linked to updating the UI. In other words, in order to get to the next state of the UI, I had to have done some action. And consequently, by conflating history and behavior, you end up with admonishments like this. And you get really weird situations, say, in a multi-step wizard. Suppose you have a 12-step wizard, OK, using the Web 1.0 model. And I go, fill out the first 6 pages. I've gone, next, 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 next. And now I remember I made a mistake 3 pages ago. So I click the previous button, previous, previous, previous. And then if I click the browser's back button, which I'm trained to do as a user, that actually moves me forward. So I click back, and I went forward within the wizard. That's bizarre, but it's an outcome of the Web 1.0 model of HTML dumb terminals. The other one that gets especially annoying when you're doing, say stock trades, for example, or around Christmas time when you're buying those last-minute gifts on Amazon. Don't click submit twice, or we'll charge your credit card twice, and implying that it's your problem as a user, right? But it's the same basic architectural problem. To do anything at all, you have to go to the server and go to a new page. So it really is an awful situation for users, because suppose that the network hangs. Some server along the way hangs. So if it's Christmas time and you really want the order to go through, you have to wait. You don't have enough money in your account to afford to get charged twice, so you don't want to hit refresh or post it again. And yet you want to be sure it goes through, so you wait, and you could wait forever. Anyway, bad situation. OK. In the Web 2.0 world, the world of Ajax, we realize that the browser is a capable, albeit frustrating, platform for app development. In other words, there's plenty of firepower within the browser, but it is very hard to harness it. I don't think any of this is news to anybody. So in the Web 1.0 world, static HTML. In the Ajax world, you can do the same thing programmatically using JavaScript. Now, there's also some people like to paint this as a philosophical debate about whether you want markup-centric applications or programmatic applications. Our answer to that is we don't care. We just want applications that don't suck. So you can, with GWT, obviously we want to support integration of code with existing HTML page, so there's lots of interop with primarily declarative UI, but you can also create completely programmatic UI if you want to. So in terms of the infrastructure, Ajax can be good, not only in that it solves those usability problems, and it does, the ones that I talked about before, it solves them because by decoupling the act of refreshing the page with invoking user actions, you can update the UI in place by running JavaScript on the client, and orthogonal to that, you can make remote procedure calls back to the server and invoke actions on the server. So in the page-by-page model, there's another subtle point regarding scalability and responsiveness. In the Web 1.0 model, you create this sort of relationship between one particular browser and one particular server, because you've got session state. If the browser is a dumb terminal, then you've got to store state somewhere. So you store it in a session on a server. So that means that when I have multiple interactions over the course of using an application, I need to create a relationship between this one browser and this one particular server, which is exactly the opposite of what a load balancer really wants. What a load balancer really wants is a bunch of stateless requests. And so in the Ajax world, you can actually achieve this by moving your rich persistent state, application state, to the client, basically a running application within a web page, a bunch of JavaScript. And then it makes stateless RPC calls back to your server. So it's a better use of, it's more responsive and it's a better use of network resources, and generally would result in lower latency and better scalability. And then the other benefit of the Ajax world is you can genuinely do things that are impossible in the Web 1.0 world. So you can't have a real-time draggable map, for example, in the traditional static HTML world. So now we get to Ajax badness, and this is where GWT starts to make a lot more sense. If you have written a lot of JavaScript code, especially without the use of a nice JavaScript library, you realize that there are just arbitrary differences. Different browser vendors do different things for different reasons, but the point in terms of how it affects you is that it's just different. And so it's very hard to create one set of code that works across all the different browsers. Then so mostly the problem is the browser APIs. So if I want to set text on an element, it's called inner text on Internet Explorer and Safari. It's called text content on Firefox. Little things like that across a large code base are very annoying, but those are API problems. JavaScript itself, in theory, is not a bad language. It's just a very flexible language, which you can say is good or bad depending on your goals. If I'm writing a big app, though, I would say it would tend to be bad because of situations like this. So there's this concept in JavaScript of expandos, which means I can assign to any identifier I want as a subobject of an object. In other words, I can create fields merely by assigning to some identifier that did not exist before. Probably you've all seen this. Well, this leads to a new class of bugs that we didn't have in Java, spelling bugs, right? So this is a spelling bug. Well, you said we fix this in Fortran. Is that what you said? Yes. Yeah, right. I mean, but when JavaScript was invented, there were a different set of criteria for what they were trying to solve, and nobody conceived of writing 10,000 lines of JavaScript in the same page. So, it's not a value judgment on JavaScript. It's just a fact that you can write this, somewhere in the middle of a 10,000 line script. But the problem is, it's not an error technically. There's nobody to say that it's wrong in terms of the machinery. You can't identify it as a problem. But most importantly, you can't really test it unless you have absolute 100% code coverage on all your all the code paths within your application. But worst of all, I chose this example for a particular reason. I mean, if you look, what it's doing, it's hooking up an event handler on some element. So the way this one manifests is later on, the user clicks some button, and the button just doesn't seem to work. Nothing blows up. There's no exception. It just doesn't have the effect you had hoped it would. Okay. I won't even mention that it's very hard to do code coverage analysis on JavaScript due to a lack of tools. But we'll come back to that. So what do we really want in terms of the user experience? What we really want is no installation. This is why the web is so popular. We want it to be secure, and browsers are pretty secure by default. We want for the user it to be easy to use. That's what's nice about hyperlinks, back, forward, and so on. A familiar user interface. Users obviously love the browser. So really what we do want to build in the future is browser applications. It's a good model. But the thing is, browsers only understand JavaScript, and we have sophisticated apps to write. So something has to give. Well, what do we want as developers? We want to be very productive when we write code. We want to catch errors early and avoid the kind of dynamic typing errors that we saw. We want to be able to debug the code using powerful debuggers, especially type-aware debuggers. Make it really easy to reuse code in libraries, things that we've been doing in Java for decades. Well, a decade. But we've been doing in general for decades in statically typed languages. And it would be nice if the tool stack was free. That would be kind of cool. In other words, what we really want is Java development. OK, so here's what we have. We develop in Java, deploy as JavaScript. So GWT, we around here at Google, we call it GWT. Which makes a lot of people cringe, but I'm sorry, it just is the way it happened. So it is probably most primarily a Java to JavaScript cross compiler. We always say optimizing compiler because a lot of people assume that it's the ease of writing in Java with only some amount of cost relative to handwritten JavaScript, when in fact it's quite the opposite. It's the productivity of working in Java and better JavaScript, faster JavaScript, than you would have been able to really write by hand realistically. A lot of people don't believe that, but we can talk at length about why that's true later. But there's also debugging infrastructure so that you can actually not just cross-compile from source, but you can actually debug in Java in a high-level environment like Eclipse. I'm going to demo that in a moment. And then sort of high level, what drives us as a team is to give developers the tools to build the most ambitious of browser applications. Because at the end of the day, there's a lot of ways to create average applications. It's just that when you start doing really complex things that have to be high performance, highly scalable, highly responsive, very usable, internationalized, the number of tool chains that can satisfy those increasing criteria become dwindlingly small. We want GWT to be the obvious choice for those type of ambitious applications. So I'll show you now what it looks like in practice. This is a mail sample application that, let's see, how's the font? Can you guys see the font OK? Yeah, OK. I'm working in a regular Eclipse install. I'm going to talk about the GWT Eclipse plugin, but I want to make it really clear that you don't have to have a plugin. We'll come back to that point. But this is just basic Eclipse functionality. So I write Java code. I've created here a mail application that creates basically a mock email UI. I launch it the way I would launch any application that I'm debugging. And the result is that you get an interactive application that is currently running as Java bytecode. But it is giving me the UI that I would expect to see in the browser. So let me kind of make this point really clear. What you're seeing here is called the hosted browser. It is really Safari. But it is being driven by Java bytecode. So when you put those two things together, it gives you the best of both worlds. I'm actually in a mode, we call it hosted mode, where I'm using my IDE and debugger, but I'm seeing the app and interacting with the app through the authentic browser interaction model. So I'm seeing what it'll really look like. Just to give you a sense of what you can do with this, this is the web inspector that's included with Safari. So you get some tools synergy there, which is nice. Okay. Anyway, so here's the application. This is all running client side. It's not doing any round trips at all. Okay, so the exciting part is I promised debugging, right? So I have a breakpoint already set. And when I click on any hyperlink here, it'll trigger the breakpoint. Okay, ready? 1, 2, 3, click. So now in my Ajax application, I'm looking at the stack frame where I set the breakpoint. There's where I set it, and I'm able to single step. So let's take a second and think about what kinds of benefits we're able to leverage now on the process of developing this Ajax application. Single step debugging, breakpoints, any type of breakpoint that your IDE or your debugger supports. So exception breakpoints, data, watch-based breakpoints, data breakpoints, regular old line-by-line breakpoints. I don't know, maybe there's some other types of breakpoints I'm not thinking about. The ability to look at individual string values within the debugger. These are all just sort of the normal things you'd expect, except it's client-side Ajax code that we're looking at. Another neat thing about most Java debuggers is that they automatically call the toString method on your objects from within the watch windows. You guys have seen this, right? So it's good to implement toString. We did that for the GWT widgets so that the toString method would return the HTML associated with the DOM substructure for that widget, which helps you get more of a declarative view of that same information. So here I've instantiated a contact pop-up widget, and when I select the pop-up object in the watch window here, you can see the associated HTML is down here. And if I wanted to copy and paste this into a separate editor to kind of analyze the structure, I could do that. All right, then I press resume, and sure enough, the pop-up pops up like I wanted it to. Okay, so showed you debugging, but let's not forget the types of things that we were able to do in creating this application in the first place, right? All the wizards, so the new class wizard, the refactoring capabilities, the code inspection capabilities. I can look at this in the browsing view, and I have easy access to all the. I'm really just demoing Eclipse. This is like the easiest thing in the world to demo. Perhaps the most boring thing to you if you're already very familiar with Eclipse. But realizing that you can leverage the strength of Eclipse directly to this problem of client-side rich web applications is pretty cool. Okay, so where were we? Oh yeah. Now, people who are already JavaScript gurus rightly say, well, this whole cross-compiling business, even if it's good in theory, it is annoying during development because what's great about JavaScript development is I can have an editor open and a browser window open. I can make changes to my code and hit refresh in the browser and instantly see the effects of my change, which is true, which is why we made hosted mode work exactly that way. And I'll show you how that pans out. Okay, just to remind you, so here we have this thing, this accordion panel, and the label there is called context, which was built up from this code right here. So let's say we want to make a change. Now notice that I never stopped running. I'm still running the hosted browser session. I can hit refresh, and I can continue, and the code is updated. So I get the effect I get is essentially all the benefits of Java, the simplicity of the whole edit, refresh, continue workflow and development, and really only at the cost of smaller, faster JavaScript that gets compiled. So that was supposed to be an ironic joke. All right. So now I want to tell you about the JavaScript native interface. This is, obviously interop is an important thing in this model because there's a lot of existing code out there, a lot of good JavaScript code, a lot of good HTML, and we want to make sure that it's easy to interop with that stuff. So fundamental feature of GWT is allowing you to implement native Java methods using handwritten JavaScript. So we abused the native keyword, and we ripped off, the term JNI and turned it into JSNI. Here's what it looks like. So there are things where it is more efficient to do something using a low-level method that's available only in JavaScript that doesn't have semantics that map onto Java, in which case, just dive right in. So if somebody says, well, JavaScript is faster at this one microscopic thing, you could say, OK, that's fine. I can capture that same thing in a native method, a JSNI method, and then create a type-safe wrapper around it for everybody else. So in this case, what we're using is the strength of JavaScript's regular expression engine to take a name that includes a first name and a last name, is the idea, and then find the space between the parts and reverse it and put a comma. Basically flip the name around so it's the last name first. Not properly internationalized, I realize. Does that make sense? I guess one other thing to notice is the special comment, right? The /star dash brace. That's the signal that this is JSNI. OK, are there any questions about this?
What happens to your debugger?
What happens to your debugger? That's a good question. I'll show you that. Yes?
So it is very similar to the JNI? Or?
Is it very similar to JNI? No, not really. It's only in the sense that you'd use the native keyword, and the IDE thinks of it as a JNI method. So there are sometimes when you do a refactoring and it says, are you sure you want to rename this? This is a native method. You might have binary code that would be invalidated by this rename. But otherwise, it's really just a sort of a simple binding between a Java callable type signature and the corresponding JavaScript. The types of values that you can pass into and out of JavaScript through JSNI, simple values map exactly as you would expect. So strings, they just become JavaScript strings. Numbers become JavaScript numbers. Very opaque objects, so complex object that was defined in Java, when you pass that into JavaScript, you can only treat that opaquely. Unless you want to call methods back from the JavaScript, you can call Java methods as well. So you can make calls into JavaScript, and you can make calls from JavaScript back into Java. So it threads both directions. I'll show you an example of that.
This is only easier using the code.
I'm sorry?
Without using the code, you're just plain JavaScript code.
I didn't quite catch the first.
Just plain JavaScript code, it could be bad.
Right. Well, if you do really sophisticated, right, like interactions, it might be that what you want to do is include an external JavaScript library. Let's say you have a lot of JavaScript code. And then you introduce stub or call through methods using JSNI that reference the larger window namespace that references identifiers in the JavaScript. Yes?
Do you do any kind of marshalling on that, going in and checking on the way, make sure it's name or there is a string?
We do, because it manifests as just a normal method call to the compiler, we do all the type checking that you would always expect.
On the JavaScript side?
No, when you're calling into a JSNI method here from Java. So that works as you'd expect, right? On the way back, we don't. On the way back, it coerces in hosted mode. And I don't have an example of that. But so, for example, you can make things blow up if you mismatch things, right? Which is kind of the point of GWT in the first place. If we could solve that problem, then we could write a general good JavaScript optimizer in the first place. So we can do a lot of checks, and I would call those they're at the level of assertions that we can do at runtime to help make sure you're not doing anything dumb. But the overhead of genuinely checking all that stuff in the final output would be too heavy. So anyway, how does all this work? So if you have seen a GWT presentation before, you've never seen this slide because I just made this one. OK, so it's kind of neat plumbing. I mean, even for a Java environment, to being able to change your source code and refresh and continue running without having to stop and restart is still kind of unusual. And the way we made that possible is through a compiling class loader. So it's actually easiest to trace these arrows backwards. So if you start at the top left with the hosted browser, that is driven by objects from this compiling class loader. The compiling class loader gets a request for a class from the hosted browser, and then it asks the JDT compiler, which we host internally. Thank you, Eclipse. And then it goes and fetches, indirectly it requests source files, which have to go through a processor that rips out the JSNI code that I just showed you and does some special fix-up as we compile it. So it comes from, the IDE affects the source files. We slurp those in, rewrite some things for JSNI to work, compile those to bytecode in RAM, answer the request in the class loader using the bytes that we just compiled, and that's how we deliver bytes that can be run in the hosted browser. The full details about this are probably fairly excruciating, but is there anything about this that anybody wants to talk about? Yes.
So you have the bytecodes, but at some point you're tapping into the native browser interaction. So
right.
There has to be some kind of dispatching at the bytecode level.
Right.
The browser container, right?
Exactly.
But that would that vary from different browsers?
Yeah, the question was, at some point you're interacting at the lowest levels with the browser. And does that vary based on the browser that you're using and the environment? And it definitely does. That's one of the harder things that we do. So that JSNI rewriter, the way that it transforms your source is that it parses the source, it finds the JSNI blocks, it rewrites those as regular Java methods that aren't native that do two things. One, it takes the stringified version of the JSNI source that you wrote, shoves it across a custom platform-specific channel into the hosted browser, and then invokes, we have this whole invocation stack, that invokes that logic that we shoved into the browser. So take the bodies of these methods, create little thunks, shove the definition of the method into the browser, and then when the thunk gets called, it routes the call into the browser and the result back. So it's very platform-specific.
So what browsers do you run on?
So right now it's each of the main development platforms' primary browser, or sort of most known browser. So on Windows, it's Internet Explorer that we host. On OS X, it is Safari, and then on Linux, it's Firefox.
No Opera.
No Opera. Although I'm happy to say that one of the next big pushes that we're doing now is switching this around so that instead of having exactly one hosted browser that we choose, hosted mode will work so that it is simply depends on a browser plugin. So we flip it on its head. You can run this plugin in any browser that we can support, and hopefully Opera will be in that list. And then you can test across a lot of different versions, even on the same development platform. Another cool thing is, for people running on Windows, this has been a problem. They want to use Firebug because it's got a great DOM inspector and some other things. They want to use Firebug in combination with hosted mode debugging. You can't do that right now because on Windows, the hosted browser is Internet Explorer. When we switch it to the plugin-based model later this year, you will be able to combine those two things and any other tools that you want. So pretty exciting. Oh, cool, thanks. Okay.
Does the current version of Wix supports the new features in Firefox 3?
Well,
On the new JavaScript stuff?
so basically, we don't do anything very clever with the JavaScript. We do parse it, but generally we leave that untouched.
It's a generic JavaScript that works across different browsers. The JavaScript.
That we might need to talk about that more in detail. I'm not too familiar with the specifics. So you can see that the architecture really is independent of any IDE, but I want to talk about how we integrate with Eclipse specifically. So let me do that. We are working on an Eclipse plugin now, finally. We did want to make sure that we're kind of IDE neutral because a lot of people have different preferences for different for what they want to use. And there are a lot of good IDEs out there, but we want to add a lot of value with one IDE, and Eclipse is going to be that one. At least that's the one we're going to work on. So I talked about JS&I, and I'll just show you a couple of things that you can do. I mean, most of this stuff I really won't even waste time showing you, because I think you'll be able to guess what it does. Like the new project wizard. The point of this wizard is that you can be up and going with a brand new project in just a matter of seconds. I haven't actually timed it, but I believe it's actually seconds, not minutes. Maybe minutes, probably, hopefully seconds. One of the things I'm kind of proud about is that you can, the Eclipse plugin is going to work with multiple different GWT releases, so we can release them independently, which means we can give you plugin updates more frequently, but it also means we can do kind of a cool little thing, which is provide a special runtime version of GWT for open source contributors, where I can actually work on the live projects that are checked out onto my local client, not from jars. So we think that'll make it a lot easier if you're actually a contributor, and obviously all of us on the GWT engineering team at Google will use this mode as well. So you can step right into the authentic source for all the libraries and make changes right there. Hopefully give patches back to us. Okay, so that's one thing, the new project wizard. Some of the other things that are probably most interesting. Actually, you know what? I have notes about this. I was going to show you all that, but I'd rather leave more time for Q&A. So our philosophy is to try to pepper GWT functionality throughout Eclipse, not have a separate top-level GWT menu for like everything that you might want to do. So everything would be context sensitive. So for example, one of the things that you would often want to do is take an HTML page that has a reference to some GWT module. So this page, for example, this is an example of including the mail sample. It's how that module gets included. So it would be really nice to be able to sort of say, debug this in a hosted mode session, and just kind of go. And it'll start the HTTP server and set up all the config stuff that you'd want automatically. The same thing is true for unit tests, and I don't have a chance to really show you, but you'll be able to right-click on a test case and say, run this test case using GWT's JUnit integration in the same way that you can do that with regular JUnit test cases now. Let's see. So the other cool thing, just to give you a sense of where we're going, we want to make sure that the plugin makes it easy for people to get started with GWT, but also that it really rewards you even more if you're a very sophisticated GWT user. So when you're doing some of the most complex stuff, we want the plugin to provide you a surprising amount of support, even when you're doing corner cases. We're not there yet by any stretch, but we're sort of getting there. So this is a sample app that I created that just basically shows the JNI. Somebody asked about setting what happens when you call a native method. I wrote an app that does this. Hosted mode is, I admit, still a little bit slow to start. So I set a breakpoint on the declaration line. So right here. And this is the best we can do right now. We haven't yet figured out how to integrate deeply enough into the Eclipse debugger to let you step through the JavaScript as well. That would be the holy grail. That would be really cool. Yeah, that would be cool. I mean, I'm definitely not promising that. Okay, all right, that would be great. That was one of the other things I was hoping would come out of this event today, is I could make some connections who might have some ideas about how we could do that.
You look at Rhino?
Yeah, we use Rhino to parse the...
I mean, Rhino has to swing debugger.
Yeah, I mean, let's talk about how we could do that. So this is going to call that method, and you can see this is really the best we can do. It does let you, well, I thought it did. Maybe we've made some changes. Yeah, it does let you check the, well, no, I guess it really doesn't. Sorry. We must have lost this somewhere along the way. I've been out doing presentations instead of using GWT, but it used to be the case that you could look at this parameter value on its way into the call. For some reason, I'm not getting that right now, but.
Is it running now?
Yeah, it is actually. So anyway, that's the example of it running, but where the features start to come in, things like, this is, I mentioned being able to call from a JavaScript block back into Java code. And to go back to somebody's question earlier about how is this similar to JNI, this is one way in which it's sort of similar to JNI. Like if we were to specify which overload of the Java method we wanted to call, you specify the type names using JNI syntax here in the parameter list. But what this is doing, it's a method I can call setTimer that would call setTimeout, which is a native JavaScript API, that when it's done would call back into my Lambda here, which then would call back into some Java code. And so the kinds of ways in which the plugin is helping, this is normally would be formatted, green or whatever, like a comment. But we're actually parsing and formatting the JavaScript for you so that you get syntax highlighting. We also do things like, let's say you made some sort of obvious syntax error that's not even valid JavaScript. Then you get errors like you'd expect. So there's some small amount of help we can provide there. We can also, this is the one I'm pretty happy about, is these are very verbose identifiers like that. It's because we need to be very unambiguous about how to map back into the Java code. But it's easy to make a mistake. And now, though, if you make a mistake, we can flag that.
This is a good example of mixing Java code and JavaScript.
Yeah.
This here is a JavaScript this.
Right.
This example, this keyword is a JavaScript this, right?
Yes.
And then the object that follows that is, the method that follows that is a Java method call.
Yes, that's right. I didn't test this, to be honest. This could be a bug. I write JavaScript so rarely now. There's a special case, some JavaScript guru here.
Special ID.
Well, so it's this really funny thing that happens when you lose the this context in JavaScript in certain situations. If there's a JavaScript guru here, please remind me. But in which case, you have to do this funky trick where you do like that.
Oh, yeah. That's a sure thing.
Yeah.
This or that this.
Exactly. So
It's an ID problem.
the other thing I just have to demo because I'm proud of it is refactoring also works now. So suppose we call it do timer finish. If you notice down below in the JSNI block, you'd want that reference to be refactored as well. And it is supposed to have been. Let me try that again.
Oh, you have an error.
Oh, yeah, I think. Do I?
Yeah.
Oh, yeah, OK. So I am. This is like totally bleeding edge code. The plugin is pretty new, so excuses and so on. Does it work? Yay! It did work. All right. Yay.
Just so I understand, that callback to Java, it's not like you're really executing Java ultimately, is that right? It's just whatever the on-timer finish method gets compiled down to as JavaScript.
Well, there's actually two modes. So we talked about hosted mode. In hosted mode, it really does do that because we have to have this distinction between bytecode and JavaScript, and we magically wire it all up. So in hosted mode, it does do the hard thing. In web mode, it does exactly what you said. That becomes just more JavaScript, and so it's a very easy transition from one to the other. And again, the reason you need such an elaborate identification mechanism for what thing you're referring to is because you lose all type context within JavaScript. So you have to have something that you can just unambiguously identify as you're parsing the JavaScript code. So.
One thing to clarify, earlier we talked about browser dependencies, and that was purely for hosted mode, right?
Right.
Or the runtime mode.
Right.
Are there any browser dependencies there? Because it's all JavaScript at that point. So my question is, are there flavors of JavaScript? Are there incompatibilities?
Right. So the question is basically about when you compile it to JavaScript, what are the dependencies on which browsers and all that. So this is a whole other topic that we really don't have time for, but there's a subsystem within GWT called Deferred Binding. And the purpose of Deferred Binding is to actually create not one output file, but actually multiple output files, permutations, such that each one can be independently optimized for a particular target, basically.
So there's basically browser sniffing and runtime.
Right. Exactly, right. So startup is two-phase startup. You send down a selection script that decides which permutation should be fetched, and then you fetch that permutation. The benefit is you pay one small sniff cost at the beginning, but you've been able to optimize that permutation with all the knowledge of the specific platform that you're targeting. It has really dramatic effects on the size and speed. Let's see. So I think that's pretty much the big thing. To provide a little more context, and then let's do Q&A. Actually, our plugin is the worst GWT plugin that I know of in its current form. The stuff I showed you has been, like other vendors have been doing this for actually like 1.5 years, 2 years. So in IntelliJ, they have great support. There is a NetBeans plugin that can do this. There's SciPal Studio, which is an Eclipse plugin that's been available for a long time. But we'd also like to see deeper integration with other great tools. Instead of us reinventing the wheel, we want to integrate with existing good tools. So Selenium, find bugs, code coverage with Emma, and so on. So there's an area we're continuing to think about. But one other great Eclipse plugin is the Instantiation Squid Designer, which has a whole bunch of stuff. All the stuff I showed and a lot more. So WYSIWYG, drag drop, editing, I18N, RPC support, all the idioms that we use within GWT, they support directly in Eclipse in the plugin. So here's an example of, you could just do drag and drop, sort of Visual Basic style. But what's better about Instantiation's approach, if you've not heard of it, is that it actually writes the code that you would have written by hand as you drag and drop things around. So it's not like this opaque thing. You can then go edit that code, and then it'll pick the changes back up. Now, if you've ever looked at this problem, you know there are limits as to how much you can edit that code. But as long as you stay pretty much within the pattern that's there, you still really can touch it. It's not too fragile. And then other little things like internationalization. We emphasize doing a lot of things statically in a compile time. So it makes it easy for tool vendors to write tools that go in and find the internationalization strings and so on. So they did a really good job with that. And then I'll talk about the community, and then let's do Q&A. We're all open source. Everything is Apache 2.0. There's a contributors list where the open source contributors talk. There's 700 or 800 people on that, and it's really active. And then on Google Code project hosting, there's something like 308 projects that are labeled GWT. So, and some of them are, I would say, quite non-trivial. Some pretty, as you'd expect, there's a lot of just sort of half-done projects, but there's some really good stuff too. So if you're interested in borrowing some existing code, check those out. So with that, let's just open.
I know that Gmail and Google Maps precede GWT,
right?
And each one has their own framework and so on.
Mm-hmm.
And my question is, use of GWT within Google right now is only with Google Health, is that correct?
Use of GWT within Google, is it only with Google Health? That's not quite true. There are some additional applications, but yeah, I'd say that the pipeline is only now getting full. So, because if you think about it, the set of people that we hired to work on those apps were the few people in the world who were, good at Ajax and really liked working in that environment. So there's a lot of momentum to keep doing things the way that they have been. But they're starting, I think, more and more teams are starting to see the real unique benefit of this approach. Yes?
Are there any limitations on the widget set that you use?
Are there any limitations on the widget set?
Subset of SWT or anything like that?
So the question is it a subset of SWT? I should have clarified, we didn't talk about the libraries too much, but it is not supposed to be Swing or SWT, actually. It's a framework that was created. That's not a framework. It's a set of widgets, basically. And they're modeled on things that a browser can do efficiently. So as opposed to like a Swing or trying to take Swing or SWT, which I've heard of people trying to do, those are really designed for desktop capabilities. And you really need a different set of APIs when you're talking about what the browser can do naturally. Yeah, there are lots and lots of little specific examples of how that manifests. But one way in which it's most different is that almost all styling and even some aspects of layout are delegated to CSS. CSS is a great part of the web technology stack. It's really efficient, it's powerful and declarative. And so when CSS can do something, we don't make you write code to do that same thing. We tell you should use CSS. Yes?
I have a question about Ajax calls that you do making back to your server. When you're using GWT, when you're writing Java code that's then going to become JavaScript code that's going to call your Java code.
Right.
How does that work, and do you guys have any recommendations on how that works?
So there is a complete RPC mechanism too. And it's something you can use outside of the UI. If you want just to use like rich RPC, you can do that. And the way it works is you define POJOs or just whatever type of objects that can be serialized. And when we compile, you define an interface that declares your services, which are basically methods whose parameters and results are serializable, like RMI basically. Right? Yeah, and then at compile time, we compile client-side proxies for all the types, the serializers and deserializers, and then we have a servlet that you can use, or a library if you're not using servlets, a library you can use that understands the wire format. And so basically you get all Java RPC back and forth across the wire. It does all the stuff, even the heavy lifting stuff like what do you do about cycles in your object graph? It handles that properly.
And from a security perspective, you were mentioning that you can go to any server or whatever. Somebody mentioned that Google Mail, for example, doesn't use this. But if I want to check my email, for example, and it's got to go out and talk to the server, obviously there's some identification information that has to be passed. And is that something that is kind of left to us to handle however you choose?
Yes. If you didn't hear that question, the question is how do you deal with authentication and cross-site authentication and general authentication issues with regard to RPC? And yes, it's left to you as the application programmer. We expect frameworks will be built on top of that layer, but it's really just the lowest level of plumbing. And maybe I should have said that too. GWT is really a pretty low-level framework. It's about giving you lots of leverage on creating code. What code you choose to create is really your call. We would expect that different companies, they have different use cases. So they're going to build up their own vertical frameworks that work really well for their particular set of use cases. Hopefully using a high leverage tool set in the process is the idea. Yes?
There's a model I've seen in some JSF toolkits that are primarily server-side, and these are server-side constructs, server-side controls, that they manifest some behavior onto the client side, and there's a JavaScript execution at runtime, but it's really more of a low-level rendering rather than the higher-level elements. Do you have any? It sounds like here the bias is really towards, like in other Ajax toolkits, where you have the full conceptual model on the client widgets. Are there any plans to do more server-side blend where you're sending just the rendering commands in JavaScript to the browser?
Yeah, so let's see what's the most succinct way. They asked me to repeat the question. So basically, Yeah, the GWT model right now is to assume that the client, what's running in the browser, is as if it were a thick client, more or less. All the application logic runs there. At least the client-side application logic does. There's an alternative architecture where you treat the browser more like, it's almost like X Windows. You treat the browser like just a rendering engine. You run the UI manipulation logic even on the server, and you send down commands to the rendering engine. So it's a powerful model in some ways, and there are lots of implementations. I think the Eclipse RIA approach is this, right? And there's some other companies. ThinWire, I think, is another example. Ice Faces and so on. ITMill. The way we look at it is GWT would be a great way to create that kind of system, because you need efficient client-side code in order to make that client-side renderer work really well. And that's what ITMill, for example, did do. Their client is written in GWT. And that also does give them some continuity in how they expose an extension SDK. So for example, if something is too heavyweight to render it just through deltas from the server to the client, you can actually add genuinely client-side GWT widgets as part of it. So instead of sending down like all the descriptions as to how to render some table, which is kind of a verbose thing to say, I can just have a table widget that I add to the stack and send down small amounts of data that, with the knowledge of that there is a table widget there. I don't know if I said that well, but now I do have a reservation, an admonition, I guess, about those type of architectures, which is that they really don't scale, basically. Does anybody think that I'm wrong about that? I mean, I've never seen an explanation of how that could possibly scale, and I can see a lot of reasons it can't scale. It creates that one client, one server affinity that I was talking about at the beginning that's like the antithesis of what you want in a load balance system. Plus, it means that I suffer a high latency internet round trip for more or less every interesting interaction. So let's say there's validation logic as I type in a text box. With GWT, if you use it sort of at full power, you would run that validation logic. Typically, you would run it in the client if possible. Suppose it's just like, is this a well-formatted email address or something, right? You'd run that in the client. Well, suppose in this other type of architecture, you'd have to send back a request to check what to do on every single keystroke. That becomes, maybe that's a caricature, but
you can think of it as you've got some fixed number of cycles that it's going to take to do this, right?
Yeah.
They run on the client or they run on the server.
Yeah.
So the more you move to the client, you've got more clients.
Right. That's basically true too. Yeah.
Server.
Right. I mean, he's saying that it obviously scales better if you can distribute work out to the client. So that's sort of as you said, that's sort of an obvious reason it takes load off the server. That's definitely true. But then in terms of like massive scalability to say millions of users, if you've only got, say, a dozen servers, and at Google we have like 3 dozen, but you've got, say, 10 million users, there's a lot of contention. And if my load balancer has this extra constraint placed on it that I've got to, this particular user has to hit this particular server, that's not the arrangement that you really want in order to support a large number of clients at once. We still have a little bit more time. I mean, there's a whole bunch of stuff. All these topics are things that we could talk about. Yes?
We're actually running over now into the break time. So if people want to ask questions, I just wonder if people want to use the bathroom or questions.
Well, we can meet at 10 past 4.
Thank you.